Welcome back, learners. So now we are moving on to the next part of our questions, which are the application questions, and they are still based on the reactions between an acid and a metal hydroxide. So then, the first question that is given on the application question says, how can a metal hydroxide be formed in general? So a metal hydroxide, we know that needs to be any metal, and the metal can either be in group 1 and group 2, as we can commonly use those ones. However, we know that the bulk of the periodic table contains the metals, which are found on the left-hand side of the periodic table, and towards the far right, that's where you find the non-metals. Then in between, forming a zigzag, we have the non-metal, the semi-metals, or known as the metalloids. So, how can a metal hydroxide be formed in general? So that needs to be a reaction between a metal plus oxygen. So that reaction is going to be metal hydroxide. So that needs to be a metal plus a hydroxide. The hydroxide is coming from water, so it's going to be a metal plus water to form a metal hydroxide. So the hydroxide that is going to be reacting with this metal, it will be coming from the water, because that's going to be our H2O. It has the OH within itself. Then question B says, give an example of a metal hydroxide of any group 1 element. So looking at the metal hydroxide of any group 1 element, we know that it starts with a hydrogen, but hydrogen, it is not a metal. Hydrogen, it is a non-metal. It is there only because it behaves like the elements that are found in that particular group. So we can use the next one, or the one just beneath the hydrogen, which is our lithium. So lithium hydroxide, we can have LiOH. So it's our metal and our hydroxide. So give an example of a metal hydroxide of any group 1 element. So Li, lithium, is found in the group 1 elements because its name, it is the name of that group, it is your alkali metals. So all the elements in that group, they are known as the alkali metals. And all the hydroxides, they have the OH. So this combination or this compound has an OH within itself, so therefore it's your metal hydroxide. Now, the next question says, we need to match the names of the substances in column A with the chemical formula in column B. So we have potassium hydroxide, lithium hydroxide, calcium chloride, sodium sulfate, calcium hydroxide, and sodium hydroxide. We do know that the potassium has a chemical symbol K. It is a metal. And then, as we have said, the hydroxide, they have the OH. So the combination of these two things, the ratio we may not be sure of, but the combination is going to be giving us the potassium hydroxide. So there must be a K and the OH so that we can have our chemical formula. Then the next one, lithium hydroxide. We know lithium, Li, hydroxide, as we know, it is OH. So the ratio we may not be sure of. How many lithium do we have for the number of the hydroxides? We may not be sure of the ratio, but what we are sure of is the chemical symbol of lithium is Li and the chemical symbol of hydroxide is OH. So that combination will be giving us the lithium hydroxide. Then same thing goes with the calcium chloride. We know calcium, chemical symbol Ca. Chloride, it is Cl coming from chlorine. As I've said again, we may not be sure of the ratio as to how many atoms of calcium we need for them to react with a certain number of chlorines so that we can form our calcium chloride. But what we are sure of is the symbols, it's Ca and Cl. The next one, we have sodium sulfate. The sodium, we know that it has a chemical symbol Na. It is a metal. Then the sulfate has the symbol SO4. So that means the symbol of this compound needs to have an Na and the SO4. And then the second last one, calcium. Calcium, we know calcium, it has a chemical symbol Ca. And then the hydroxide, it is OH. So they need to have those particular substances, the Ca and the OH. And then the last one, sodium hydroxide, which is the Na and the OH. So we may not be sure of the ratio between the two atoms. All we know is that the symbol for each of these things needs to have an Na and the OH. So now we can get down to the balancing of these particular substances. So the name and the column and the chemical symbols. Starting with the potassium hydroxide, we said potassium, it is K, and then the hydroxide, it is OH. So that means number 1, it is your KOH, potassium hydroxide, so which is there. So that is dealt with. Then the next one, lithium hydroxide. We said lithium has a symbol Li, and then Li and our hydroxide, it is OH. We may not be sure of the ratio, but we do know what the symbols are. So the lithium hydroxide is going to be that one. So number 2 is going to be LiOH. Capital letter I, small letter, capital letter L, small letter I, and then capital letter O, capital letter H. Then number 3, so that is dealt with. Number 3, we have calcium chloride. We know calcium, Ca, chloride coming from chlorine, Cl. So CaCl, which is going to be this one here. As we have said, we are not sure of the ratio, but all we know is the symbols need to have the Ca and the Cl. And as you can tell from this molecule, from this compound, is that we need 1 atom of calcium for every 2 atoms of chlorine. So that ratio we're not sure of, but we know that the symbol needs to be CaCl. Then there's a 2. Right, then that is dealt with. Then we need to go to sodium sulfate. We said sodium, it's Na. Sulfate is your SO4. Again, we said we're not sure of the ratio, but the symbols are Na and the SO4 for the 2. So that means it is going to be that one there. As you can see, for every 2 atoms of sodium, we need to have 1 molecule of sulfate. Or to break it down even further, for every 2 atoms of sodium, we need 1 atom of sulfur and 4 atoms of oxygen for us to have our sodium sulfate. So the number 4, it is going to be Na2SO4. Then the 5th one, calcium hydroxide. We know Ca, calcium, hydroxide, OH. So obviously the ratio we are not sure, but we know that there must be a Ca for calcium and the OH for the hydroxide. So what we have here is the Ca and the OH, which then means for every 1 atom of calcium, we need 2 molecules of the hydroxide. Or we can say for every 1 atom of calcium, we need 2 atoms of hydrogen, also 2 atoms of oxygen, because these 2 that is outside the bracket as a subscript, it goes for everything inside the bracket. So that means we have 2 oxygens and also 2 hydrogens. So the chemical symbol or the chemical formula for that is Ca. It is Ca bracket OH close bracket and then the 2. And then obviously the last one. So that was dealt with and this is dealt with. The last one, sodium hydroxide. Obviously, that's the remaining one. We know sodium is Na, hydroxide is OH. So therefore, the chemical symbol for sodium hydroxide is NaOH. So right, learners, with that said, and all of those are those names of these chemical compounds that have been matched with their chemical symbols, we're just going to go for a quick short break and I will see you just after this.